So I'm Guillaume Lagaillarde. I'm running a company called 1.2. We are doing simulation in France. And I'm also a distributor for standard products in France. And I'll have this small talk about stadium egress and bleachers and how bleachers are connected to stairs in stadium. And I will show you a very small case study which answers one question I had with architects about how to design stairs and how shall we connect some stairs to an exit platform on a stadium. Okay. Okay, so if I take a stadium, FIFA requirement or the green code requirement ask an egress in less than 8 minutes. So it means that for a huge stadium, here in this case it's 30K fans stadium, you have to evacuate the whole stadium in less than 8 minutes. Okay, sometimes you also have people on wheelchairs. And an interesting thing also to know about stadium is that they call this, just disappeared. Okay. So in French, we call that a vomitoire, a vomitory, which gives you a good idea of how people are supposed to exit the stadium, fast and in bulk. And in fact, it's what everybody wants. And there is one good reason why people want that, is that because in all those stadiums, there is a big competition for space between safety and money. So if you take a stadium, you have always this thing, you have bleachers with lots of people seated, then you have stairs, and then you have exit platforms, and then the vomitory, where people have to exit in bulk and fast. And this is money, because people are paying. So as a stadium builder, what you want is you want as many seats as possible in a small space. But on the other hand, and of course this is big money because this is a VIP place. But also, if you want to fit this less than 8-minute evacuation, you also need space for stairs and for vomitories. And of course, this is not money. And anytime you try to improve the evacuation time, then you have to enlarge your vomitories, enlarge your stairs, and then the result is that it's less seats, and less seats is less money. And there is a specific thing about all the stadiums we are studying is that there are one geometry which is kind of complex, is bleachers. And stairs, the complexity of this is that stairs are multiply connected with seats. And then it means that you can't just, in any simulation software, shall it be Pathfinder, shall it be Mass Motion, or any simulation software, you can just say, oh, it's a stair. And it will behave as a stair. Because it's a stair, but it's a stair with as many doors as alley you have. And also, between two alleys, in fact, in a real stair, we'll have 2 steps. So what shall we do with this geometry? And the other thing which has been mentioned by my colleague
Guillaume.
Really? Shall I start it again? No. Okay, so anyway, it was not interesting. The interesting part is after, so don't worry about that. But yes, what I was saying is that when you do a simulation project, behind that there is, as a consultant, because we are not researchers, there is always a customer who wants results fast and who has no money. So we need to be very fast constructing building the model. And sometimes you say, oh, he will send me his IFC file. The architect will send me the IFC file. I will just import the geometry, populate my model, click on the button, and then got the result. But it never works like that. And one of the reasons it's even more difficult with stadiums is that there are some specificities about stadiums we don't see in other projects. One specificity is those pyramidal stairs, because if you want to have more seats equal more money. It means that you don't need to have those large stairs up there because there's nobody. Okay? And also, one thing which is annoying when we import those IFC files is that the slabs here, all the slabs, they are non-flat. And there's at the beginning I was thinking, oh, there's non-flat because it's a mistake, but no. They are non-flat because it's outside and they want that the water just flow. So they're slightly twisted or slightly slopey. So it's another difficulty for us because we love those flat rooms. And also, as it's large space, you've got those dilatation joints. And architects, they love to be very precise, and they will put all the dilatation joints everywhere, and then you have to click everywhere to change it. Then if you do it manually, it's just not possible. So it's tricky and it's time consuming, and for us, time is money. Also, something I forgot to say that it's not only important for evacuation, it's important for every event, because when you have a stadium, you are interested about evacuation in case of emergency, but you're also interested in evacuation on every event, because it means security people, because you have to evacuate at the end of each event. So it's not only a safety issue, it's also an economic issue. Okay, if I come back to Bleachers, what we have found in our project that it's very useful to build a library of Bleachers that you will be able to copy, paste, and modify in different projects. Otherwise, it takes too much time. And if you think about a bleacher, you have back seats, exit, you have front exit stairs. Don't forget about this area, the hide and kiss area. Teenagers will appreciate if you don't forget to modelize this area. And then you need to, we found out that having a huge library of those bleachers can help a lot making the project. Okay, so here comes the case study. And this is the very precise question we had to answer from the architects. In Abidjan Stadium, there are two options to link the exit platform to the bleachers. One option was to say, okay, then they will walk this way, take a stair, and then walk this way and go out. And the other option was to say, okay, each alley will walk, take a small stair, enter the exit platform, and then walk. And the very interesting thing was that option A and option B are absolutely identical in terms of number of seats. So same money for A and for B, but maybe one of the two is better than the other. And so the idea was, okay, now that we know that we are not losing any seat using A or B, can you help us to choose if we have to design it this way or if we have to design it this other way. Construction cost was about the same. So it's an interesting case study where simulation helped architects take decision, which is not always the case because most of the time architects, they already have taken their decisions, regardless the result of the simulation. So what we did is we built a small model of each case. This is option A, this is option B. And oh, maybe I can use this fancy thing. How does it work? Oh, come on. Oh. OK, do it like this. OK, so there are exactly the same number of people, 1,028. They have got exactly the same characteristic. In fact, they have been made by copy-pasting and just modifying the connection. This is option A, with people going and then going up and turning. And this is option B, with people going in small stairs to the platform. Come on. OK, and if we do this simulation, if we try to compare those two situations, we can see that, in fact, here, they are emptying quite fast these three LAs, while, come on, OK. While here, they are still stuck here because they just move here and they are blocked by people going down. But at the end, the thing which is quite deceitful somehow. OK. But at the end, it does not make any difference. So the evacuation is about the same for A and for B. Which was bad because I preferred this one than this one. But reality is that it does not make any difference. And if we think about results, if we look more carefully about results, these two curves compare the flow rate of exit in situation A and in situation B. And what we see is that the green one is A, or B, I don't remember. Yeah, the green one is B, with people coming from the side. And we can see that at the very beginning, the rate is higher. So it means that the people from the alley, they go out faster, and you've got a higher rate and a higher exit rate. But once those guys are out, then the surface, this surface is about the same as this surface, and then option A get back quite fast. And then after it's symmetrical, it's identical. So what we can say that option B gives better result during the first 30 seconds. Then option A get back to and equalize. And then at the end, for the last part of the simulation is the same. So it leads us to one interesting question also, is that most of the time we just look at total evacuation time. The first indicator we look is, OK, do they go out in less than 8 minutes? And what is the evacuation time? But if we think about it, it's not the only indicator we should look at. We should also look at maybe average evacuation time, maybe first people to be saved, or maybe time when 95% of my people are out. And in many models, we try to minimize the evacuation time, and we put a lot of effort trying to gain those seconds at the end to be under the 8 minutes. And in fact, we're just concentrating in 1 or 2% of the population. And we don't look at all those guys who could be saved because they just went out first. So in this case, finally, this video helped the architect to choose this option with people coming from the side. And it's a good example on a case where small simulation lead to a decision that convinced the architect to change his plans. Okay, as a conclusion to that, also I would say that when we do those simulations, we always show those fancy video. We always put the 3D appearance with those guys, and somehow people get fooled by very fancy 3D outputs. But we all have to remember that, in fact, we are not doing this. We are doing this. We are doing this with cylinders, and it's the best we can do. And this is what we do, but people think we are doing this. And what we lack is we put a lot of effort in trying to find ways to adapt hard models and hard geometries to those bleachers and those stairs. But we have no data. We have no measurement of how fast you go from an alley to a stair, to a perpendicular stair. And we are just obliged to make assumptions, to make modifications so that the model works, but there's no guarantee that what we're doing is reality. It's just a model, it's just a simulation. The good point of this is that somehow people think it's very precise, and they buy the result, and they take their decision. It can be a pity, but on the other hand, it's something good, because somehow you manage to help people taking decision with the best tool you had. But just we have to remind people that they're taking their decision on that, and they are not taking their decision or this fantasy of a twin stadium. There is no twin stadium. There is a model that is based on very simple assumption of cylinders working at the speed with a direction. Okay. Thank you.
Great. Questions in the room? Okay. Let's go this way.
Hi. First of all, thank you. It was very interesting. I was wondering, you mentioned at the beginning the 40 centimeters of the aisles, and I was wondering how you implemented that in your model.
I cheated. Now, in a model, oh, sorry, I went too fast. I just cheated. I said I'm on the moon, and it worked. No, in fact, what we did is that we just erased the seats. And we assume that if I've got an alley like that plus a seat, I just assume I've got an alley like this. And then I just enlarge my door here. So you are forced to cheat somehow, because your cylinders cannot sit. So as your cylinder cannot sit, and as you're not doing a micro simulation, a sort of ergonomic simulation with people with legs and arms and everything, then you have to just remember that your agents are cylinders. So then you need to adapt your geometry to your agents. There's no other way. And that's why it's legitimate to cheat, because you have a cylinder that is averaging a very complex person. Then your level of detail is this. And if your geometry level, if the level of detail of your geometry is somehow much higher than the level of detail of your agent, you're making a mistake also. You need to have something which is homogeneous in terms of hypothesis. This is why we cheated. And we cheated with saying, okay, we just get rid of the seats and enlarge the access to the stair. But in reality, the access to the stair is also enlarged because you've got those two steps and you can access here or you can access here. So it's legitimate to enlarge your access because it's already enlarged.
And I would add one note about that. In Pathfinder, for example, there is a parameter that lets you change collision with geometry,
Exactly.
and you can make it more narrow so that an agent who is wider could fit through a geometry gap, but still have the correct interpersonal distance between other agents. So that is a capability in Pathfinder, but this is a
There are many ways
basically
to
both ways
work
you cheat.
around the
You
question,
just
but both
move
ways
them
are
through.
cheating.
Correct.
But it's not cheating, it's just making simulation.
Correct.
Okay, next question. You mentioned that you had problem with passing from the real geometry to the model geometry and not spending days and days doing hand by hand. How do you manage to do the model from reality to something real?
No, I did it hand by hand, and I paid one of my guys to spend time just clicking everywhere and just because the point that maybe there is a clever solution, but the point that when you face this problem or with all those joints or with maybe those twisted things, then you just know that you got to get your result within 10 days or within 1 or 2 weeks. So of course, Sandra is very reactive. So we exchange a lot. I send them questions. They send me, oh, try this, and for example, we managed to make all the surface flat because there is a small options, and Pathfinder is full of options. In fact, full of small options. But the reality is maybe there is a better way to do. Maybe when I will get this add-in from Revit to Pathfinder, I will find something very, very interesting to do that. But practically, I just clicked everywhere and then merged all my rooms, and that's it. Okay. But I first removed the seats from the IFC file to export my whole alley without removing the seat one by one. But this is the only thing I did.
Okay, we do the same, but with simple model. Maybe Pathfinder a solution in the future to make fast model.
Go ahead and enter that into our feature request. Thank you very much. Yeah, definitely there's always these, I would say these kinds of models, the big stadia, the arenas, things like this. This is always the most complicated and the most tedious kind of model because you have so many connections, so many doors, so many relationships, different surfaces, and every architect has maybe the geometry is really nice coming from the architect, but usually not. So then you have to interpret it and connect it and do, so this is probably one of the hardest kind of use cases, but also really a great use case for tools like this, because if it was simple, you could just do it with a hand calculation, right? But now you have 30,000 agents going in different directions. You need something more complex. So, but yeah, this is an ongoing development effort.
But that's why building a library of bleachers and of typical things is very useful. Then you keep your library and then you copy paste from one model to another, and it saves time. But there's no magical way. That's why we get paid, in fact.
So you changed the geometry because of this 40 centimeter problem. It sounds a little bit too much work. So did you think about making the pedestrian ability smaller? Because in this kind of geometry, the shoulder is not a decisive factor, I would say, rather the legs. And when we move, people move in the stadium.
Yes, you're somehow right, but I did not want to change the geometry of the people, nor to change the speed of the people, because it's too much of a cheating. Because if you change the geometry, for sure they're smaller, for sure they evacuate faster.
No, not necessarily, because if you think about it, people in the stadium, they move freely in these alleys. And although the shoulder is 40 centimeter or more, why? Because the legs, they don't have 40 centimeter diameter. So it's natural movement. And if you make them smaller, I mean, here people, mostly this is a single file movement. It's not a crowd in the sense of, so it's not too much heating, I would say.
I don't know.
It's rather
sincerely,
realistic.
I don't know, because here it's a crowd, and here there are stairs. If they are smaller, they are more in parallel. And well, but you're right. There are many ways to work around this problem. I prefer to cheat enlarging these doors, because finally what happens here is not very important, because what makes the difference is the time to access these platforms, and then what happens upstream does not have an impact on the output. But I wanted to have realistic people here, because I don't want to have too much people in the stairs, and I don't want them to be more to have a higher density here than what would be in reality.
Yeah,
but you're right. It could be both things are possible.
And that's what the geometry collision issue is. That's what that feature is to help resolve, is they can step through 20 centimeters easily now, but still have the correct shoulder width, the correct crowd density, interpersonal distance. Those
One
all
thing
are
you can do is you can reduce their size here and change their profile once they're here. But it takes too much time. It's too long.
Just one last comment. When you do the simulation, I see that the end exit is just at the end of the vomitaries. Do you take into account the accumulation of people outside the stadium, like in the exit platform, if there is queuing there?
In this model, yes and not, but they just have a small wall here. There is some obstacles, but not that much. And as it's in the open air, we consider they're out. But in other projects, we are taking into account what's outside. But in this case, there's a high density here. Once they're out, it's open air, and they're considered safe. Also, just we have to remember that the whole objective of this is to prove the FIFA, the French football, the Football Federation, that we evacuate in 8 minutes. We don't want to just add obstacles, so to be more realistic and make them evacuate in 20 minutes. Otherwise, we cannot build this thing. The problem in those studies that who's paying, and sometimes, even if you're very honest, the guy who is paying you orientates your work. There's no way to make it different.
Thank you. Thank you very much.
Thank you.